Alright, please take a look. Today what we're going to be doing is looking at an ion. And we're looking at an ion as a metal atom that has lost electrons, or a non-metal atom that has gained electrons. So far, all we've done has been looking at the structure of the atom, finding out how many protons there are in the nucleus, how many electrons there are arranged outside the nucleus. And now yesterday we learned about the structure of neutrons, that the nucleus also contains a second particle called neutrons. And those neutrons, if you're comparing two different types of atoms, and they have the same number of protons, but a different number of neutrons, we have isotopes. Now we've got a brand new word that also begins with I, but talks about a whole different type of thing. Isotopes, dealing with when you're comparing atoms with a different number of neutrons. Now we're dealing with what are called ions, and you're talking about one atom that either gave away its electrons or gained electrons. So we're going to be dealing with ions, atoms that are losing electrons or atoms that are gaining electrons. Now, what I would like you to do is I'd like you to take a look at question number 1 on P12. Question number 1 on P12 has to do with the element of sodium. Question number 1 on that ion worksheet has to do with the atom of sodium. Now, on that drawing underneath for sodium, what we have learned how to do, because sodium is number 11, yes, what we've learned how to do with sodium is we've learned how to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've learned how to draw 11 protons in the nucleus. Because sodium is in row 3 of the periodic table, I learned how to draw 1, 2, 3 energy levels for sodium. Because sodium has 11 electrons, 11 protons in the nucleus, and 11 electrons arranged outside the nucleus, I've learned how those electrons are arranged. I've learned that in that first energy level we've got 2 electrons. And in that second energy level we've got 8 electrons. And in that final energy level for sodium, there is only 1 electron. The way I know that there is only 1 electron in that last energy level for sodium is it is in column 1A. Column 1A immediately tells me that on the very outside we have 1 electron. We have 3 names we've been using for that 1 electron. We call it the outer electron, the bonding electron, or the valence electron. 3 different names that indicate the number of electrons for bonding, valence, or outer electrons. There's sodium. Now, please take a look at letter A for question number 1. It asks what the charge on this sodium atom is. Well, right now, we just drew 11 positive protons, because sodium is number 11 on the periodic table. We also just drew 11 negative electrons. So I have 11 positives and 11 negatives. Neutral or no charge. We can use either one of those 2 terms. Both of those mean the same thing. So this atom is neutral or there is no charge. Either one. No charge. Now, the second part of that, letter B, says, how many valence electrons does sodium have? Well, there is only 1. one valence electron. So letter B, we would write 1 for question 1B. And then letter C, it says, would it make more sense for sodium to lose or gain electrons? Now, we haven't talked about this yet. This is the first time any of us have seen this idea of an ion as an atom that's either losing electrons or an atom that's gaining electrons. Now, later we're going to write this down in our notes, but just watch right now. We're going to have what's called a magic number, which equals 8. Here. Magic number equals 8. So that means, what that means is on the outside of every single atom, what that atom desires, what that atom wants is 8 electrons on the outside. There's one exception. Energy level number 1 only needs 2 electrons. But everybody else needs 8 on the outside. Right now, you can see sodium only has 1. So sodium's going to have 2 options. Sodium can get or gain 7 more electrons. Then on the outside it would have 8. Or, here's the other option. If sodium gets rid of that electron, gives it away, that means its last energy level is empty. That means that last energy level goes away, and in energy level number 2, it now has 8. So it's got 2 options. We'll talk about in just a second which one it will do. Okay, so we've got letter C making more sense. We'll talk about that shortly. What I want you to do is now look at P13. Now look at P13, question number 1. We're going to do a drawing for some oxygen now. We're going to draw oxygen. So, for oxygen, it's number 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 8 protons in the nucleus. 8 protons in the nucleus. And because oxygen is in energy level number 2, row number 2, I'm going to put 2 energy levels. 1, 2. 2 energy levels for oxygen. I learned how to arrange these electrons in the energy levels. So I put 2 electrons in the first energy level. And in the last energy level, I put 6. And the way I know that it's 6 is because it's in column 6A, which indicates that on the outside there are 6 electrons on the outside. So let's answer some questions about oxygen now. The first question about oxygen states, what is the charge of oxygen? Well, here I just drew 8 protons in the nucleus and 8 electrons arranged in the electron cloud. And so once again, the charge is 0. No charge, neutral, 0 charge, however you want to say it, but there's no charge for that atom. No charge for the atom. Letter B asks, how many valence electrons, or how many bonding electrons, or how many outermost electrons? We could get that from its column number without even drawing it, and there are 6. 6 valence, or 6 bonding, or 6 outer electrons. And then it says, for letter C, would it make more sense for it to gain or lose? Now we can make a decision. What I want you to notice is these 2 atoms are very, very different. This one has quite a few electrons on the outside, and this one only has 1. Our magic number is 8. That means every atom wants to get 8 electrons on the outside energy level. And it will do it by either losing electrons or it will do it by gaining electrons. What I want you to notice is oxygen already has 6 outer electrons. That means it's very close to having 8, but sodium only has 1 outer electron. So it's pretty far from getting 8. It would have to gain 7 more. So here's what our rule is going to be. If on the outside energy level, if the atom only has 1, 2, or 3 electrons, what it will do is lose the electron.